So by now you will probably have seen those cool time lapses on regular filament-based printers where the print is standing still and it's just coming out of the bed, it's just being built as is, and you don't see any printer movement, it just appears. And those look incredibly cool. I've showed you how to do those with the Octolapse plugin in my Octoprint configuration guide, which I link somewhere up here, I think. But you can also do the same thing with resin printers. But it is a bit trickier to do that because resin printers typically don't have the interface to trigger a camera or a webcam as is. So there are a lot of things that need to be just right to get those epic shots. We are going to use a gadget today, and that is the Resin Lapse made by Uncle Jesse and Andrew Sink, fellow content creators here on YouTube and on TikTok. And that will allow us to get the camera perfectly in sync with the printer, but there are a lot of other things too that need to be just right for this to work, including lighting. I'm going to show you a couple of tricks how to do that with very simple equipment. You don't even need to buy anything usually. Camera settings, how to power your camera so it doesn't run out of juice while you print. But to start, I'm just going to give you a baseline of what a resin time-lapse typically looks like if you just do, your regular setup. You don't do anything special, you just point a camera at it. So I'm going to switch to lighting real quick to my regular overhead lights. 1 second. There we go, so that would be your typical workshop lighting. And for the camera, I'm just going to use one of my ZV-1s. Those are the cameras I use for streaming and as a B cam for this sort of stuff. I've got it in program auto, autofocus, auto ISO, just everything at stock. The only thing that I did change is that I've got the interval shooting mode enabled, so it's going to take a photo every 60 seconds. We only need roughly 1,000 photos to make a good 10-second time lapse. And thankfully the Sony cameras actually show you how long the entire time lapse is going to take to shoot if you have a certain interval. So an 8-second interval in this case with 1,000 images is going to give you those 2 hours that the print is going to take. So I'm going to set this, I'm going to point it at the printer. There we go. And I'm just going to hit go on the camera. This is going to keep running for those 2 hours. I'm going to start the print on the SL1S. And while this is printing, I can tell you about today's sponsor, JLC PCB. JLC PCB is my personal choice when it comes to ordering custom PCBs and getting them with the SMD parts already assembled. Honestly, being able to just whip up a circuit and then getting the finished product in the mail a couple days later with all the ICs, resistors, capacitors, diodes, etc. already in place has absolutely changed what I'm able to do with my own electronics designs. To order, you simply export the standard Gerber files from your PCB design software, upload them to JLC PCB, and they will automatically match the components in your design with the components they offer. And if it's something that they don't have, they can now even get those parts for you from other electronics distributors. JLC PCB have no extra fees for the SMT setup or stencils. You only pay for the board, shipping, and the components you use. Check them out at the link below. All right, it is the next day. The print is finished. The print itself came out beautifully. Let's check out that time lapse though. So in case it wasn't clear, I'm not actually putting the camera into what Sony calls slow and quick mode, SNQ, or using the time-lapse mode on my phone. We are actually taking individual photos every time the camera gets triggered, either through the internal intervalometer that we're using right now, or through Resin Lapse that we're going to use in a second. That just gives us a lot more flexibility in when exactly we're going to take the photo, and also we get a bit extra image quality. We can use the full 12 megapixels of this thing, and we can crop in later and do all sorts of stuff with that. The way I turn those image sequences into a video is I just drag them into DaVinci Resolve for me. That automatically picks it up as an image sequence and it shows up as a video. But there are also standalone tools that will just take an image sequence and spit out a video file that you can then do whatever you want with it. But if we take a look at the time-lapse itself, there are a couple of issues with it. It doesn't look great. Not that I expected it to look great on the first try, but there are certainly some things that we can improve. The most striking one, I think, is that we just can't seem to see the print really all that well. So I did print with the cover closed as you're supposed to. So what you will often see is just people printing with the cover open. In my case, that's going to work. I can leave the cover open because I'm all on LED lighting and there are no windows, no open windows in this room. So I don't have to worry about the resin hardening from just ambient light. But if you are still using incandescent lighting, fluorescent tubes, or have windows that aren't completely blocked in your printing room, This is a recipe for disaster. You're just gonna slowly harden the resin as it sits open. So cover everything, use LED lights, and then you can use the printer with the cover open. Now the other thing that we can improve, of course, is lighting. Right now you are seeing the studio lighting, which is a big key light over here and a bunch of fill on the other side, and then of course the background lighting. And that of course is set up in a way where I can just place anything in the studio and it's generally gonna look all right. It's probably gonna look better than in real life, which is helpful for me standing here. But you're not typically going to have that lighting setup. So what typically is going to look better than just overhead lighting is some light coming from the side. There is no overhead lighting on right now. So what you can do, and what I'm actually doing in the studio as well for the background lighting, is just grabbing one of these cheap IKEA, I don't know what they're called, I'm going to call them pixel lamps, and just add a bit of your own key light from the side. So something like this is going to be too much. That is just going to be way too harsh of a contrast. If you have a white wall that you can bounce this light off of and just give you a bit of a side light, that is going to massively help, or just reduce the intensity by moving this away a bit. And that is immediately going to give you a crisper edge. You can experiment with this and just, give yourself a super contrasty look by going from the side or even from the back, and that's going to create some really dramatic shadows and contrast areas. Or you can also grab one of these LED panels or use colored gels on these lamps and add a bit of lighting contrast by doing that. It is very easy to go like overly stylized and like high color contrast with these, but maybe that's the look you're going for. So experiment with the options you have, maybe add some light blockers, some reflectors. You can use styrofoam panels, for example, if you really want to go in depth. There are plenty of tutorials on YouTube when it comes to setting up a photo or video lighting setup, and those are generally the same tricks that you want with setting up a video, an epic time lapse of a resin print. For me, I'm just going to stick with the studio lighting because that is all set up in the perfect way already, and I'm not going to have to futz around with extra LED panels or stuff like that. It just makes it easy for me. Now, one thing that I was actually surprised about was that the camera was working so well. So I kind of mentioned that I just intentionally left this camera on full auto, including autofocus and auto exposure. What could happen, and what often will happen, is that the camera, for example, sees the darker print coming out and now thinks, oh, this is darker, I need to up the exposure, which can lead to some very nasty lighting changes. And those are super hard to correct for. So to avoid that, and to avoid, for example, the camera starting to focus back and forth, we're going to set this to all manual. So I'm just going into my camera's mode selection here, and I'm going from P over to M. And now we can manually set the exposure, the aperture, and the ISO. So let's start with the ISO. We're going to set that to the lowest one that our camera offers without going into a low mode, which is marked with these bars here. So 125 for this. Then I'm going to crank up the exposure until we're roughly exposed correctly. There we go. So we have this meter, which is at 0. That's what we want. Maybe a bit underexposed, depending on what look you're going for. I'm also going to zoom in a bit just to give us a bit more of a dramatic look. The widening look can look cool on a slider, which we're going to get to later. But yeah, just a bit more zoomed in like that. That's going to be good. And I'm also going to set the camera over to manual focus, if I can find it. There we go. So we're going to go to MF, and now we can make sure that this is in focus, and it is. I've got focus peaking on. So now during the entire time lapse, nothing is going to change about the way this image looks. And it really does help to have a print already in the machine, already in the position where your final print is going to end up. So you can make sure that the print itself is going to look okay and not the rest of the printer, because this is what you're actually caring about. And the last thing that you will have noticed is that our time lapse was not actually complete. We didn't get to see the print complete. We only got about 3/4 of the way through before the camera ran out of battery. So that is one of the challenges with these smaller cameras, with the smaller batteries. They don't last forever. This one apparently 90 minutes and that's it. So thankfully Sony cameras do have the option to just use a power bank and plug it in through micro USB. However, that is the same port that we're going to need to trigger it with the resin lab. So Sony uses what's called a multi-port, and this is not just micro USB, this is like 9 pins instead of 5. And you can either plug in a remote shutter release, or you can plug in a power bank. but not both at the same time. There are adapters for that that split out a remote shutter release and a power input, but those are either pretty expensive, like 50 bucks, or super hacky if you build one yourself. So what I would recommend is just grabbing a dummy battery like this. So this is not the correct one for this camera. This is a Canon one, but you can get them for pretty much any camera. You'll be able to plug it in through USB into a battery bank or a charger or something, and it's just going to replace the actual battery. You slide in this dummy and it's going to power your camera forever. So that's the solution that I would recommend with a simpler camera. My A7S III has an extra power delivery USB-C, so I can use that. But for everything else, dummy batteries, probably the way to go. I guess one last thing that I can mention before we start the next print with the updated setup is that I did take care to orient this part so that the face of Stitch here in this case faces out of the printer, not into the printer. So we actually get the front of your print showing while it's printing it. Now, of course, once we take it off the platform, it doesn't matter which orientation it was printed in, but because we care about the time lapse and the process of it printing, we do care about the orientation. During slicing, just make sure that your part faces the correct direction. Some slices, unfortunately, have that direction backwards. That's just something you're gonna have to know about your printer. So with the setup updated, with lighting, with the camera settings, and the camera not running out of juice, I'm gonna get this part off of the platform, and then we're gonna see how much of a difference we already made. Yeah, this is already so much better. Now, I'm happy with this. I would use this in a, in a video review, and I've done that before. I've done these simple time lapses, and they work, they look great. But we can make them even better with the Resin Labs cables. So Andrew sent me 3 cables. I believe these 2 are identical, but this one has different plugs. So these are for Canon, and they use the 2.5mm headphone style connector, while the one for Nikon has, I guess, a proprietary connector. I'm sure this is like some sort of standardized obscure thing, but it's got a different connector. But they all share the same sensor head, which is really just a photo transistor. So the idea is this thing, you stuff it into the bottom of your 3D printer, and it detects when the UV curing LED turns on, and with that, it triggers your camera. Now, most cameras, including the Sonys that I use, allow you to input a remote shutter, and basically all that shutter does, I've got a cable for this here, is it shorts out 2 of the pins in this connector, and that acts the exact same way as pressing the shutter on the camera. You can short out 2 other pins, and that's like the half-pressed focus state, but all we need for a time-lapse is the shutter itself. So unfortunately, they're not making a Resin Labs cable for Sony cameras yet. I think the multi-port connector is actually the limiting piece here, because these are kind of tricky to work with. But thankfully, I do have a cable from some other slider or something, and we can magically combine these into one. So there is my hacked up Resin Labs to Sony multi-port connector. All I did basically was to tie these 2 in series, and I added a 10K resistor because by default, the way that this photo transistor is switching was a bit too sensitive for these Sony cameras. So now what I can do is I can just plug this in, and you're gonna see on the screen, once I point this towards the light, it takes a photo. And once it sees light again, it takes another photo. So now all that's left to do is to fandangle this into the printer and make it see the UV LED, and we've got ourselves a time-lapse setup. All right, quick test to see whether the Resin Labs sensor is in the correct spot inside the printer. Let's do a display test. Did it trigger? No, it didn't. Okay, we're gonna have to move this around a bit more. All right, that should do the trick. I zip tied it right between the LED assembly and the lens, right in between there, and now it reliably triggers the camera. Also, I found a spare M3 threaded hole, and I'm just using that as strain relief. Nice. So at this point, we've got everything ready to use this setup with Resin Labs and to trigger the camera on point with every new layer as it's being started. Now, there are 2 more things that we would need to change in the camera itself. And the first one is that we're actually going to take it out of interval shooting mode. We're just going to put it on the regular single shot again. So every time the trigger gets triggered, it only takes one photo and it doesn't start the next interval that the camera triggers. The other thing that I would highly recommend that you enable in your camera is the electronic shutter. Some cameras call this silent mode because instead of using the mechanical shutter blades in front of the sensor, it just does all that electronically and you're not wearing down your shutter element. With the amount of individual photos that we're taking for every single print, which is thousands of layers and thousands of photos potentially, you could be wearing down your mechanical shutter within, I don't know, 50 prints to its rated lifetime. So you definitely do not want to do that if you get the shutter stuck. They are a pain to repair. So on my ZV-1, I've already got this enabled. It's got shutter type, mechanical, auto, or electronic. You definitely want to set it to electronic shutter only. Now, from here on out, I will actually be using my Sony a7S III for these time lapses simply because it has that separate USB-C power input, and I do not have a matching dummy battery for the ZV-1 that I could use to power this camera for more than 90 minutes. So the a7S III is all set up. It's plugged in to power through USB-C. It's getting the Resin Labs input, and I also added this pink LED panel just for good measure. Now all that's left to do is to remove the model from the platform, refill some resin, and we're ready for the time lapse. And yeah, this is it. This is exactly what we were going for. Add a little zoom effect to this, maybe a bit of motion, and you've got yourself a really decent looking time lapse. But just one more thing, one little extra sprinkle on top, and that is using a slider like this. Now, I've made a video about, building your own slider with open build profiles and an Arduino before. This is one that I bought because it has that rotating action. And while the slider is moving along, it's actually going to pan your camera, which is going to create some really amazing effects because everything is in sync. And I was already getting worried that I may have misplaced the remote to this slider, and I was thinking about ways of how I could control it and keep everything in sync. Like, what if I wire up the motor in here to the Z-axis? That would create some really interesting effects. But thankfully, the remote turned up and I can just use this as intended. So I'm gonna get this set up and hopefully we're gonna get some epic time lapses to watch. Yeah, that turned out pretty much as perfect as it's gonna get. I love it. Now going into this video, I wasn't sure how well this was all gonna work together, but I'm super happy that it is working as well as it is. Now, of course, I am using some fairly expensive and high-end hardware to achieve these results, but like I showed you earlier, you don't have to have the fancy studio lighting, the slider, or an expensive camera. You can make do with simpler things. For example, I think you could even wire up the Resin Labs to a phone, because the way that you trigger the shutter on these is by shorting the mic pin to ground on the headphone input. That's basically the same as pressing that button on those old wired headsets. If you have any other tips for getting great time lapses of your 3D prints, leave them in the comments below. Actually, JLC PCB are giving away a $50 coupon to the top 8 most upvoted comments below. I hope you guys had as much fun watching this video as I had making it. Do the usual things, like the video, comment, get subscribed. If you want to support the channel, Patreon, YouTube memberships, you know the drill. And most importantly, as always, keep on making, and I will leave you with one more time lapse, and then I'll see you in the next one. Bye!